So we are going to do Spark for next 28 hours, and after that we'll have more 4 hours for a capstone project. So these are the 28 hours that will basically clear your concepts and make you ready from the interview point of view as well. And this is the 4 hour that will be something that you can add into your resume saying that you have worked on this project, and so that your profile gets shortlisted, as well as you have something to say on what you have exactly worked on Spark. So this is the entire plan. To introduce myself, my name is Harish, and uh, I'm into this IT industry from last 10 years, and in big data and Hadoop and Spark related stuff from last 5 years. And from last 1 year, I'm also doing almost more than 1 year. I'm also doing 1 or 2 years. I'm doing machine learning as well, right? So this is my profile. And before this, I worked on mainframe systems. So starting 5 years, I worked on a mainframe kind of a system. Then for 5 years, I worked on in data engineering side. And from last 1 to 2 years, I'm working something on machine learning as well as the machine learning on the big data systems. So I will call it as a data science. So what we'll be learning is Spark. Any questions until now, anyone? Okay, perfect. So if you have questions, just feel free to stop and then we can discuss on it. So let's discuss about Spark, and today we'll do introduction to Spark, how the picture came in. So in the year 2000s, companies started seeing that the data is increasing, right? And the companies who were facing this challenge were mostly Google, Yahoo, and other such companies, including Facebook and so on. Facebook relatively later on, but Facebook was also one of those. Especially Google, we can understand that what the Google's main product is a search engine. So for a search engine, they have to do a web scraping and they have to store the data from all the websites in their server so that they can later on search or run the queries on it to provide the search results. So since Google had to store a massive amount of data, they can definitely not store in a single server. I mean, no matter how big is the server, they can definitely not store in a single server. Similarly was the case for Yahoo, and similarly were the case for Facebooks and many other companies going forward. So it was very much clear they cannot store. Reason being, they have some limit on which beyond which the cost increases exponentially, as well as you cannot go beyond certain amount of storage and RAM and processing power because of semiconductor issues or limitations. So all this company had to go for something called as a parallel processing, or connecting multiple computers or multiple servers in parallel. So what these companies did was, instead of using a single machine, it was very much obvious that they had to use multiple machines. So Google was doing internally something, Yahoo was also doing something, and so on. So Google was called as a GFS, Yahoo was doing something that was later on converted into a open source Hadoop project, and that's Hadoop. If Facebook also uses Hadoop extensively, and whatever big companies they use Hadoop extensively. So Hadoop was the first, it was a first open source project. It was a first open source project for distributed storage, resource management, as well as compute, right? So Hadoop was the first such project that came, and that was open source. That is, the code was freely available around 2010 to public. Before that, also Yahoo was using the same thing, and that was solving the problem of distributed storage, resource management, and compute. So what I mean by distributed storage is, if I am storing a data, some data in this machine, some data in this machine, some data in this machine, I have to keep somewhere the metadata. Where is my data, right? So that's a distributed storage, and that was taken care by Hadoop. So basically, where it is storing the data, it will be fault tolerant, and so on, that was taken care by Hadoop. As well as when the job will be run, there has to be certain resource manager who says that, okay, this computer is relatively free, run over here. That's again a resource manager that was present in Hadoop. And compute is basically how to run the program in a distributed way. So this is how the Hadoop evolved, and it started gaining more popularity. So Hadoop was having basically three different layers. If you want to draw something for Hadoop, it was having three different layers in Hadoop 2.0, right? Again, let's write what were the layers. The below layer was for storage. That layer was called as a HDFS. So the bottommost layer was for storage, and that particular layer is called as a HDFS. So HDFS stands for Hadoop Distributed File System. The second layer was for YARN. This is for resource management. What do you mean by resource management? Basically, what is a place where the resource is available so that I can run my jobs over there. So that kind of a work was done by a resource manager, and the name of the resource manager was Yarn, yet another resource negotiator. Again, once you Google Yarn, then just don't Google Yarn, just Google as Yarn Hadoop or something like that, because when you Google Yarn, you may also find some Yarn similar that is present in Node.js. So don't confuse with the JavaScript Yarn, but this is a different Yarn, that is a resource negotiator for a Hadoop. And finally, there was a compute part, and that layer was called as a map reduce. So map reduce is basically consist of two different programs, map and reduce, that were used for a parallel processing, right? So this is how the Hadoop evolved, and it started gaining popularity from 2010 onwards. The popularity increased, and it increased until 2018 or 2019, or in fact I will say 2020 itself. And now the popularity is decreasing a bit for Hadoop, right? Of course, Hadoop will not go anywhere, Hadoop will still be there, but the popularity is decreasing. People are exploring how we can use only Spark and not use Hadoop. So we'll see why, but the Hadoop basically gained popularity from 2010 onwards, and I will say it was gaining a popularity until 2020, and somewhere in 2020 it's stopped getting popularity, or the rate at which the popularity was increasing is slowing down in 2020, right? Or it's reducing, because there are other ways of doing it as well, and that is basically directly using a Spark. But before going to Spark, let's see what happened to Hadoop and why people don't want to use it. So we said until now that there are three layers in Hadoop. One is for storage, HDFS, that decides if I want to store a file, that file should be stored in which machine has a free storage, and so on and so forth. And second thing is Yarn. Yarn decides that whenever someone is submitting a map reduce job, it should be executed in which particular server, this server or this server, or which server, that is taken care by Yarn. And MapReduce is nothing but a code that is written in Java, mostly in Java. It can also be written in Python. So the MapReduce is mostly the code that is written in Java that is going to run in all these machines, right? Again, there are certain different versions of Hadoop that came in. Previously was 1.0. So 1.0 is same only. There is no such difference. Only difference being there was HDFS layer, and this complete layer was called as a map reduce layer. So there was no separator as such. The everything was taken care by a map reduce, right? So this was called as a map reduce, and this was still there as a HDFS only. So from Hadoop 1.2 to 2.2, what happened is Yarn came in, and the way in which the jobs were handled internally changed drastically, right? Because of a separate resource manager and more proper handling of job and so on. Then the most recent version that was launched in 2020 only was Hadoop 3.0, that is having a more better storage layer mostly, and it is more fault tolerant and so on. But if you see most of the companies, or in fact I will say all of the companies, they are still using 2.0, right? So if you are working on Hadoop, you will be working on 2.0. Again, if you see 1.0, there is not much difference. Only difference is some functionalities will be less, as well as this complete layer was called as a map reduce. If you see 3.0, it is still the same. Architecture is still the same. There is a few improvements in it, performance wise, as well as on the storage side. But if you want to study, you have to study 2.0 only, right? So this is about Hadoop and how the Hadoop itself look. Now the next question is, from 2020, why is the popularity for Hadoop going down, right? Again, it's not the popularity for Spark that is going down, right? We are not saying anything is happening to Spark. In fact, the popularity of Spark is continues to increase, right? Even now. But the popularity of Hadoop started going down from 2020 is reason being, once the Spark came in, Spark was a replacement for a map reduce. So Spark was a replacement for a map reduce. Again, HDFS was there, Yarn was also there, and Spark was basically a replacement for a map reduce. Why it was a replacement? Because when Spark came in, I mean, Spark started in 2010, that's another case. But when Spark came in and gained popularity, especially in 2014 onwards, uh, the RAM was very comparatively more accessible or more cheap, right? RAM will be mostly referred as a memory. So whenever I say a memory, it is a RAM. And if I am saying a storage, it can be SSD or hard disk. So in 2014, or whenever the Spark came from 2010 onwards, the RAM was cheaper. So whatever Spark did, Spark is known for an in-memory processing, right? It is known for its in-memory processing power. So what do you mean by in-memory processing is, whatever processing happens, the intermediate data is stored in a RAM. Okay, memory means RAM. So what does Spark do? Spark does a in-memory processing. So when I say memory, memory means RAM. So a Spark does a processing in RAM, whereas the map reduce for intermediate storage, it uses a HDFS. HDFS means hard disk or SSD. So what will be fast? Will it be a RAM that is fast, or will it be the hard disk or SSD that will be fast? Obviously, RAM will be fast, right? So what will be fast? MapReduce will be fast or Spark will be fast? Spark will be fast, right? So the first question is why the MapReduce is getting replaced with Spark? Reason being, uh, it is an in-memory processing framework, and obviously that is more fast. That is one of the reason. There are other reasons also that we will be seeing, but this is the main reason that it is doing a in-memory processing rather than doing a or keeping the intermediate data in hard disk, which will be comparatively slower. So what happened is Spark was fast, so people stopped using MapReduce and people started using Spark instead of using a MapReduce. Now, since people started using Spark instead of MapReduce, they also started to see one more thing when they were working in on a Hadoop cluster. Let's say this is my let's say this is my 50 node cluster. Okay, this is my 50 node cluster. 50 node cluster meaning 50 servers are connected in parallel. Okay, 50 node cluster meaning 50 servers are connected in parallel. Each of the server is having a storage space. Okay, each of the server is having a storage space, as well as each of the server can do a compute. So what people started noticing, or what the developers or architects started noticing, is now for each of the machine, though the data is increasing exponentially, the data is getting full. Okay, the data is getting full, the hard disk is getting full. In most of the machine, the hard disk is getting full. So if the hard disk is getting full, what should we do? If the hard disk is getting full, what can we do? Can I connect more computers in parallel? Yes, right? I just have to connect in parallel, right? So what I do, I connect more computers in parallel. Let's say 50 becomes 60. Okay, so this also data started going full. That's not a problem. I can still add a computers. But what was the problem is, at the same time, when the data was getting full, the compute utilization was just 8 or 9% or less than 10%. Okay, so CPU utilization in each of the computers or each of these servers was less than 10%. So the storage is full, reaching 80%, 90%, 100%, and so on. But the compute usage or the CPU that is getting used is only 10%. So is it a good use of it? It's waste of resources, right? So the first reason why the Hadoop is stopping to gain the momentum as of now at the late 2020, right? In fact, in 2021 start when we are recording this, the Hadoop usage is getting low and low. Reason being, people started to notice that if I'm making such a giant machine, if I'm making such a giant cluster, I'm connecting hundreds of servers in parallel. But at the end of day, I am noticing that out of this 100 clusters, 100 nodes, each of the nodes is just using a 10% of CPU. So the first reason for the decline of Hadoop in the late 2020, or I will not say decline of Hadoop, but why Hadoop is not getting popularity anymore, right? Why you are not hearing this Hadoop word a lot as you were hearing in 2018-19? Why Hadoop is not gaining popularity anymore? So the answer is true as of December 20, right? Things keep changing. So Hadoop is not gaining a popularity anymore, or not gaining a popularity as it was getting in 2017, 2018, and so on. The first reason was the CPU utilization was low. CPU utilization was low. Even though the hard disk utilization was increasing, the CPU utilization was low, and it was basically a waste of money putting so much powerful CPUs and all, right? And the second reason was cloud adoption was increasing. So the second reason was the cloud adoption was increasing. So since people are moving towards a cloud, cloud is nothing but the server is with the Azure or AWS or Google. So let's say I am bringing this server up, a 60 node server, a 60 node server on a cloud. Let's say this is my Hadoop, right? So this is my Hadoop cluster, and this is a 60 node, 60 servers are connected in parallel. Each of the server is having a storage, each of the server is having a compute power, right? Compute power meaning CPU and RAM, storage means hard disk. So each of the server is having this thing. Now, if I bring this 60 node cluster or 60 node server on a cloud, first thing, can I bring this server down on Saturday and Sunday? Can I bring this servers down on Saturday and Sunday? Can I say that, okay, my business is only from Monday to Friday. Let's say I'm using it for some banking purpose, for generating reports and so on, and I am only generating a reports on Monday to Friday. Can I bring this server down on Saturday and Sunday? Can I shut down it? Sorry, no. So can I shut down? Can I shut down on Saturday, Sunday? The answer is no. Why? Not really. Bringing up is not really. You can just bring by writing some scripts and scheduling for Azure or AWS, and it will come up automatically before even if you reach office at every time morning, it will come up. So bringing up is not an issue. What was the second? Any other way? Any other answers? Bringing up is just writing a two three commands. We'll see how to bring up a server as well. So why I cannot shut down? Let's say I am on the cloud, I am on Azure or I am on AWS. I have used a 60 node cluster. I have loaded my data. Okay, I have brought my data from everywhere, right? I have brought my data from doing a, let's say, doing getting a data from a SQL server. I'm getting some data from I'm getting some data from uh, mainframes. I'm getting some data from Oracle over here. Okay, and Monday to Friday I'm making a report. Saturday, Sunday, can I shut down these machines? The answer is no. I agree. I cannot shut down the machine on the cloud. Obviously, I cannot shut down or I cannot just destroy the resources on cloud, right? Or shut down, because until you destroy the resources completely on cloud, I will still get a billing, right? So my question is, can I shut down or destroy resources, right? Resources meaning the server, whatever instance we have taken. Can I shut down or destroy the resources on cloud? Can I destroy this 40 nodes that, okay, I will say to Azure on Friday, okay, I don't need this. I don't need because it is Saturday and Sunday. I don't want to use. So can I just destroy it on weekends? The answer is no. But I'm still waiting for some reason why the answer is no. Data also, we will lose the data. So that's the perfect answer, right? We will lose the data. Okay. No, to avoid data loss. So that means I have to keep it always up. And that is not why the cloud is there, right? The ultimate purpose of the cloud, or the ultimate purpose of the cloud computing is, whenever I need a resource, get the resource. Whenever I don't need the resource, destroy the resource. That is only the selling point of a cloud. And whenever you are using the resource, the Azure or AWS or the Google or whatever cloud provider, they will charge you. If you are not using a resource, they will not charge you. But if you are hosting this kind of a process or a 16 node server on a cloud, you can never destroy it, because the reason being, the data is over here only. The data is over here only. Data is on the same machine. The compute is also on the same machine. You can never destroy it. So if you are not destroying it, it is very costly. If you average out the cost between an on-premise and the cost on a cloud, and if you are keeping it on complete time, the cloud is far, far, far more costlier than a on-premise. Okay. The cloud is very costly. The only cost benefit comes into a cloud is when you start shutting down your machines when you don't need, and make the machine small when you don't need, and make the machine big when you need more, kind of when you are implementing a scalability. That's where the cloud brings an advantage. But if you are having such a kind of a system that is completely living always on a cloud, it is very costly. It doesn't make a sense, right? So what should be a solution if you want to implement a cloud? Okay, why I cannot have this on a cloud? The reason is, what is the reason why I cannot have this on a cloud? What is the reason why I cannot use such kind of architecture on cloud? What is the reason why we cannot shut down on cloud? Right, perfect. So we don't want to lose the data, and if I shut down for saving a cost, I will lose the data. So what should be the solution? This problem was because the storage and compute was together. So what should be the solution? Separate the storage. Okay, so that's a perfect answer, right? So the solution to this problem is, what's the solution for this? The solution is simple. Separate compute and storage, right? Separate compute and storage. So if I'm separating a compute and storage, this is my compute, this is my storage. Okay. What is the example of a storage on AWS? S3, right? What is a storage example on Azure? Blob. Blob storage, right? Data lake. Sorry, which one other thing? Okay, data lake Gen 2. Okay. And what about Google? Okay. So whatever, right? Google storage, right? So similarly, also on premise, also you can have this kind of architecture, but this kind of architecture is mostly seen on the cloud. In on premise, you will still find a Hadoop kind of a thing. But on a cloud, the storage had to be a separate, and compute. What they do is, instead of having a 60 node server, they know the CPU utilization is just 10%. Just have a 5 node server. 5 node cluster. Okay, 5 node cluster. Just have a 5 node cluster. Okay. So what you will install over here, you are obviously going to install the Hadoop, right? So you are only going to install a Hadoop. Okay. Anyone knowing the example of Hadoop on AWS? What is that service called on AWS? EMR, right? Elastic Map Reduce. So EMR is nothing but an open source distribution of Hadoop, and AWS has just modified it. Similarly, Azure is having a partnership with Hortonworks. Uh, Azure is having a partnership with Hortonworks, and Hortonworks is basically a Hadoop provider. But this Hortonworks had a merger with Cloudera this year. I think so, this year or end of last year. So when the Hortonworks and Cloudera had a merger, now Azure is also making his own distribution of Hadoop, right? So this is one of the example, right? EMR, which is a Hadoop version provided by AWS, Hortonworks distribution that's provided by Azure, right? Google is having a completely different. Google has its own query systems, and Google is a bit different, right? They don't use. I haven't seen the Hadoop installation that comes as a separate service. But of course, you can also rent a server on a Google Cloud and install your own Hadoop over there on that server, right? You can do that, but I haven't seen any services from Google from for Hadoop. Okay, so this is the some explanation about why the Hadoop is not gaining that popularity, right? So this is again a Hadoop distribution, but kind of a things have changed separately. And again, there is a different ways in which a Spark can be used, right? Spark can also be used as a standalone. So basically to run a Spark, you don't even need a Hadoop. You can just run it standalone, right? So I can have a standalone uh, Hadoop and data over here. Oh, sorry, standalone Spark. I can have a standalone Spark and can take the data from S3 or blob storage. The another reason is you can use the Spark with Kubernetes and Docker, right? So Docker is a containerized platform, and Kubernetes is the one that handles Docker as well as another containers, right? So Kubernetes is a orchestration tool for containers, right? So I mean to say that for Spark you don't need a Hadoop. So moment you go into a cloud, you want a storage, you take S3, and you want a compute, you can take a Hadoop as well from EMR of AWS or Hortonworks distribution from Azure. But you can also have it on a standalone, and you can also have it on a Docker and Kubernetes and whatever, right? So I mean, you don't need a Hadoop now, and you can do the same things. So that's the reason that recently the popularity of Hadoop is not increasing to that extent. Does it mean that I don't need to study? If you're going into a big data, you still need to study, right? Some of the companies will be using a Hadoop definitely if it is on premise, and even if it is on the cloud, they will be using some of the clusters for sure. So is it that I don't need to study Hadoop? No, you still need to study Hadoop. But of course, the things keeps changing. You also need to study Spark in more detail now as compared to if you were studying 3, 4, or 5 years before. Okay, so this is what we discussed. Let's have a quick recap before we can actually start Spark. We are just talking about Hadoop and why the Hadoop is declining and so on, but just have a recap on it, right? So, introduction to Spark. In 2000s, the data was increasing. So companies like Google, Yahoo, and Facebook were feeling the pain, and they came up with a Hadoop kind of a system for distributed processing. So this is what happened. Again, Hadoop has how many layers? Hadoop has how many layers? Three. What is the first layer? HDFS. What is the full form of HDFS? Hadoop Distributed File System. So it takes care what data to store over here, what data to store in which machine, how many storage is present empty in each machine, and so on and so forth. Second one is what in the Hadoop? Resource Manager. What is the full form of the Resource Manager, Jan? What is the full form of Jan? Yet another resource negotiator. Again, if I'm doing a Google, do a Hadoop yarn or something like that. If you just do yarn, half of the result will be for Spark yarn, and more results will also come for Node.js yarn as well. So that's a package manager over there. So uh, just it's not a JavaScript yarn. The third one, what was the original processing layer over here? MapReduce, right? So it is a MapReduce that is a again topmost layer. So MapReduce, the people used to write the program in which language? Python or Java, right? Okay, perfect. So what is the Hadoop version that we have drawn over here? What is the version of Hadoop? 2, right? Before that, before the 2, 1 was there. What was the difference between 1 and 2? Was together, right? Okay, good. 3, what was the differences that came in 3? Yeah, fault tolerance and recovery is better for the lost nodes, and performance is better and so on. Just came this year only, 2020. So uh, Hadoop gained the popularity reason was it was the first open source project, right, for distributed storage. Google and all were doing, but that was not an open source. So Hadoop was the first open source project, and it gained popularity and so on. But as coming to 2020 now, you already know that there were two major players of uh, big data or Hadoop distribution, Cloudera and Hortonworks. They both had to merge, and there was another distribution of Mapr, and Mapr was not doing a good business and going down, and it was finally acquired by HP. So it is a clear sign that the popularity was decreasing. However, after the merger, Cloudera and Hortonworks, now Cloudera did get post the good results in their report, right? So they are doing a profit, but again the popularity went down. Uh, then going to this, when they were having a 50 node cluster, if the data is if you need more cluster, more storage, more compute, you can go on adding a node and it becomes 60 and so on. But what was the problem that the data engineers, data architect notice? Yeah, CPU is not utilized, right? Because the data is getting generated like hell, right? A data is generated a lot. Even we are talking, the data is generated. So there is so much amount of data that is generated, but you don't need to process all the data, or maybe the processing is always less compared to the storage of a data because you are retaining the data for long time over here. But you just need to process the data probably once or twice. So the data is high, but the CPU utilization was very less. So if the CPU utilization is very less, what is the meaning of putting so many server? Each server cost you in thousands of dollars, or even hundred of thousands of dollars if it is a good server, or definitely 10, 20, 30 thousands of dollars for sure, right? So I'm not writing it as a why Hadoop is declining or something, but can just simply say that why Hadoop is not gaining a popularity anymore in December 2020. So what is the first reason for it? What is the first reason for Hadoop not gaining a popularity in December 2020? Yeah, so one of the reason is a cloud adoption, and the second reason is Yeah. So CPU utilization was low, right? So first reason is CPU utilization was low. And second one, this kind of a architecture does not suit a cloud because storage and compute is together. You need a compute for some amount of time only. You need storage every time. You need a storage on Saturday and Sunday also. So in cloud, definitely you have to separate the storage and compute. So if you separate a storage and compute, you make a small compute. Again, in that compute, you can put a elastic map reduce like in AWS or a Hortonworks distribution in Azure that is called as a HD Insight. Or else you can use a standalone server where you install a Spark. Or else you can also use a Docker where the Spark is installed. The image of a Spark is installed over there, right? Okay. Any questions, anyone in this till now? Anyone, any questions? Any questions, anyone? Okay. If no questions, we go ahead. Mhm. Okay. So question is, does Spark use Hadoop APIs or Hadoop functions, right? Uh, so the answer is not really. It depends again. If you are using this kind of architecture, HDFS, YARN, there could be a map reduce over here. Can have a Spark over here. So if the data is there in a Hadoop, if the data is there in a Hadoop file system, HDFS, then of course it has to use a Hadoop API to read it. Yes, it has to use it. But let's say my data was coming from S3, so no need. You don't have to go to Hadoop. You can directly read from S3. But again, again over here, it still needs to internally communicate with the resource manager, which is a yarn, right? So it still has to communicate with yarn. So not necessary because you can also have a Spark in such a kind of installation where Spark is there and it's either a standalone that is itself is doing a resource manager, or else it is used by another resource manager called as a mesos, right? Then there is Hadoop is not there at all in the picture. There is no Hadoop installed itself. There is no Hadoop. It's just a Linux machine, and on a Linux machine, a mesos is a resource manager and Spark is running. It is using a Linux storage, or else maybe a standalone. The Spark is having its own resource manager, not even using a mesos, just reading from S3. So there is no question about Hadoop itself. The Hadoop is not there at all. So
generally what we do, we put a star as a as asterisk, right, to read everything. So I just checked for whether there is any other regex pattern. So I found regex pattern, like, curly braces. Inside that you can give year number, comma, year number. So it will read only two. So actually it is something which Hadoop supports. It is part of Hadoop API, but it is supporting the Spark also supports that kind of thing. So it is internally pointing towards that thing. So I just pinged you that it's part, it is mentioned in the, the what do you call, Stack Overflow. So I just asked you.
Mhm.
That's it.
Okay, yeah, we can just explore it later on. But for now, if it is a Hadoop distribution, then it's a Hadoop command. But if it is not using any of the Hadoop distributed file system, then it's a Spark separately. So you don't have to use it, or uh, but most of the times, if you know Hadoop, the commands will be developed in the same way as well. So the syntax will be similar as well. But again, it depends. If you are using a Hadoop APIs, that means your storage is there, definitely there in Hadoop. You won't be using a S3 storage with a Hadoop API. Okay. So we can look into it later on because it will deviate from the topic. Any other questions, anyone? Okay. So let's start with Spark. So Spark was actually developed by a guy named as Mate Zaharia. Okay. In the year 2010, when he was doing his PhD, right? So when he was doing his PhD in 2010, he actually developed a Spark in his university, right? The University of Berkeley. So, and later on, it was open sourced to Apache Software Foundation. So, Spark is basically an open source project now. That is, you can find its code over there. You can see what is the code written in Spark and so on. How it is internally implemented as well, right? And as well as these guys, this Marty Zaharia and other people who created this Spark as part of a PhD project, they formed their own company that is called as a Databricks, right? So Databricks is the one that still contributes a lot to the Apache Spark. They are the biggest contributors to the Apache Spark. So whatever is the code changes that come in, or whatever are the new development that happens, the Databricks is the company that is doing most of the things, and the main guy is a Mateza area over there, and these guys founded and started this companies, right? Apart from this, they also promote a few other projects like ML Flow for machine learning. Uh, then they are now promoting a lot Delta Lake as well, which is a storage kind of a system that can be installed on top of S3, that can be installed on top of HDFS, and so on and so forth, right? So these are the few things they are promoting now as well. So Databricks being the company who is the contributing maximum to the Apache Spark. Now, if you are learning this Apache Spark, you should be knowing at least one of the four programming languages. You should be knowing at least one of the four programming languages. It can be either Scala, it can be Java, Python, and it can be R, right? So Spark can be in any of these four programming languages. It can be Scala, it can be Python, it can be Java, or it can be R. Scala being the most widely used.
Even in .NET nowadays, we can write actually.
No,
Microsoft
you cannot
support.
write a Spark program in .NET. You can call the APIs from outside, but you cannot. Spark doesn't support .NET.
I think
You
with
can
the
have a. Mhm.
latest thing, right? The Azure Synapse Analytics. There is something which Microsoft
Mhm.
lately they have started supporting uh, for Spark in .NET. So there was a demo and all lately. But
Okay.
I don't know how much it supports. But it's as you said, right? There is a distribution from Microsoft. It's called Azure
Mhm.
Synapse Analytics. So they have started supporting for .NET also.
Okay.
But how many people will write? That's another question.
Mhm. Mhm. I mean, it's not a part of a main legacy or it's not a direct support. They just provide a layer on top of it. You can also make a layer on top of any of the programming languages that calls this API. So that you will never count it. Okay. It is not a native support. So saying about the Spark, there are four languages that it supports: Scala, Java, Python, and R. Scala being the one that is most widely used, and the reason for being the most widely used is the Spark is itself written in Scala. So when the Spark code came in, the Spark was itself written in Scala. So when it came in, it was in fact a very small program. It was just 20,000 lines of the code, the initial release, right? Now, of course, it's more. So it was just a 20,000 lines of code. And it is the Spark, since it was written natively in Scala itself, the most of the people do in Scala because it is having a good support and a native support and so on, right? As well as Scala is easy to write as compared to Java. Reason being, you don't have to declare the variable types, you don't have to define a lot of methods and constructors and so on in Scala that you need in Java. So it's kind of a Scala is most widely used. Uh, you can, for more in-depth learning of Scala, we are not going to cover in this sessions. You can refer to the Scala Programming in Depth that is published by myself on uh, on Udemy, right? So again, that is a 40 plus hours of course. You can listen to that thing on Udemy. That is 40 plus hours. It covers a Scala in all depth. The second popular language for Scala programming is second popular is Java for big data processing, right? For data engineering, I will write for data engineering. Then the third and fourth is Python and R. Python is mostly written for a data science purpose. So if you are doing a machine learning and artificial intelligence, then you will be using Python. You won't be using it in for a data engineering work, right? So it's used mostly for a data science. Sometimes people also do some data engineering in Python also, but that is very rare. It's very rare that a people do a data engineering in Python because of it's bit slow as well as compared to Scala, especially the when you study RDD day after tomorrow, then you will also understand why Python is comparatively slower for in Spark as compared to Scala. But still, people use it in data science. The reason being, the Python is the most widely used language in data science itself. So they also use the same thing with Spark as well because they are most of the data scientists are well familiar with the Python language as well as the other libraries like scikit-learn. TensorFlow, Keras, and so on, right? So on, these Python libraries are available. They are familiar with all this and they use. R is very less used. People don't use R that often with Spark. Again, reason being the releases that have happened for a Spark. If the certain functionality is available in Python now, it will take a lot of time for, or some time at least, for the same functionality to be available in R as well. And mostly R is not even a language that most programmer uses. It's more of a mathematical kind of a work, or the more of a analytical kind of a work that is done in R. So people, data scientists can do some analysis in R, but again, if it comes to a deployable model, either they will rewrite the same model in C and C++ to be very fast, or else they will just do a development directly in Python so that it can be deployed as well as it can be scaled for a production use case. So the most widely used programming language is Scala. The second is Java for data engineering. Python is mostly used for data science. Again, it is also used by data engineering as well. And R is very less used. It is not used much in big data domain, right? With Spark, it is not used much. Again, since we are going to cover it, we are going to cover for this Scala. If you have not watched, you can watch this 40 plus hours of course whenever you get time in between this course, or even if are not watched, I will take care that you won't face any difficulty in understanding this. We'll be covering from the basics itself. But if you want to learn in deep and you want to clear the interviews where the Scala questions are also asked, please listen to this 40 plus hours of recording as well from Udemy. Okay, and whenever we are going to study, whatever we are going to study now, the Spark part, we are going to study the Spark with Scala. Okay, we are going to study with Spark with Scala. However, with Python also it is almost similar. It is almost similar. Okay, but what we are going to cover is with Scala. The reason being we are doing for a data engineering as well as it is the most widely used programming language. Any questions until now, anyone? Anyone, any questions?
Nope.
Okay, so if no questions, then let's go ahead. So what is Spark? What is Spark? So first thing that we say about the Spark is it is a unified computing engine for parallel data processing on cluster, right? So let's try to understand what it means. So it's a unified computing engine for parallel data processing on a cluster. So why we say unified is when the Hadoop came, we saw that when the Hadoop came, there was a HDFS, there was a yarn, there was a MapReduce. Again, people wanted many other things apart from this. Like the Facebook developed something called as a Hive for SQL queries. Yahoo developed something called as a pig for writing a scripting language. Some other companies develop Scoop. Some company develop Mouth for machine learning, and so on. Different things started coming up. So it was, so if you want to install this, you have to install this, and again install Hive separately, again install Pig, Scoop, Mouth, and so on. But it's a unified computing engine. It has everything. So if you see a Spark, so some half cut star I was trying to draw. So it has something for uh, processing, right? You can write a batch processing job. You can write a streaming job, that is a continuously streaming data, like watching a live cricket match. So it can do a streaming processing, it can do a machine learning, you can write a SQL queries over here, and so on. So it's a unified platform. Everything is built together. It's a unified computing engine for a parallel data processing, meaning you can do a data processing in parallel on a cluster. Cluster meaning a series of nodes that are connected in parallel, right? Lot of nodes connected in parallel on a cluster. So the definition of Spark is it is a unified computing engine for parallel data processing on a cluster. Now it never says that it has to be a Hadoop cluster. It can be any cluster. You can have a Docker and Kubernetes installed. You can just have a Mesos installed for a resource manager. It never says that you have to use in Yarn. And most of the time, since companies take an entire package, they have a Hadoop as well as Spark itself together with it. So most of the times you will see that Spark comes together with Hadoop, but it is not really necessary that it has to come together with Hadoop. Spark is just a compute engine, nothing else, right? It's just a compute engine. Again, it supports everything. It supports a streaming processing. That is, you can process a live stream of data. You can do a machine learning on a Spark. You can run a SQL queries on a Spark. You can write a batch jobs on a Spark, right? So all these things you can do on a Spark processing framework. Again, do I need a cluster of machines? No, not necessary. I can also install the same on my personal laptop. On my personal laptop, I can also install a Spark on my personal laptop, and I can start using a Spark on my personal laptop. So I don't need a cluster also. I can install a Spark on my Linux machine and I can start using for processing it, right? Okay. So let's just quickly revise on this and we move ahead after revising. So what is the definition of a Spark? What is the definition for Spark? Even what is the definition for Spark? It has to be interactive.
It's a unified computing engine.
Yeah,
When,
it's
when
a
we say
unified
unified,
computing engine for parallel
yeah,
data processing. What do you mean by unified?
yeah, it has batch processing, streaming. It has the interface for SQL queries and also for machine learning.
Okay, perfect. So everything is together, right? And do I need a Yarn as a resource manager, or I can also use a Mesos?
Yeah, we can use Mesos
We
as
can
well.
use Mesos, we can use Docker, we can use Kubernetes, we can use standalone. Okay, do I really need a cluster, or I can also install on my personal laptop?
Yeah, we can also do it on our personal laptop.
We can also do on a personal laptop, right? Perfect.
Yeah.
So let's go ahead. Okay, I, okay, let's go ahead. So let's see how actually the high level components look like on a Spark. So when we are going to work now, we are going to work on a Hadoop cluster, right? So just assume that or just understand that how what we'll be working is we will have a Hadoop layer on top of it, HDFS. We have a yarn. We are not going to use MapReduce, okay? MapReduce is there. We are not going to use, but we are going to use a Spark over here, right? We are going to use a Spark, right? So this is the Spark. If I want to zoom in and I want to see what exactly Spark consists of, or what are the different libraries that Spark provides, there are two layers. One is a low layer, okay? So at low level, it provides following APIs. The APIs that it provides is RDD as well as broadcast and accumulator variables. Okay, this broadcast and accumulator is not much used. In fact, the RDDs are also not much used nowadays, but broadcast and accumulator are very less used. So even if you forget about broadcast and accumulator, it's okay. So at low level APIs, there is RDDs as well as certain distributed variables. After that, on top at high level, APIs, you have a data frame, you have a SQL, and you have a data set. And it is also called as a structured API because all of this data is structured. It is having a fixed schema, right? I mean, you can define a schema for it. It's kind of a tabular data, right? If you have used any SQL tables, it is a table, right? Tabular data. If not, it is just like an Excel, right? So if you are having an Excel, it is a tabular data. So this data frame, SQL and data set, it is similar to a Excel sheet, right? It is similar to a Excel sheet. So if I see this, so it's something like this, right? If I'm having a table, roll number, student name, age, whatever. So 1, 2, 3, A, B, C, whatever, 12, 12, 11, right? So it's just a tabular data. So this is how a data frame will look like, or it is how a data set will look like, or even a SQL table will look like, something like this, right? So this is a high level data, but a lower level data is just like a flat data or a unstructured data. So it's a two levels, low level APIs and high level APIs. And what all things it support is, of course, it supports a batch processing. It also supports something called as a structured streaming. So you can stream the structured data. You can stream the structured data. It also has a lot of libraries for advanced analytics. And other libraries. Okay, you can, there are a lot of libraries that are available in Spark. You can just go and download any library, right? Let's say you want to work with Azure, you want to connect with a S3 storage on AWS, or you want to connect with the Azure Blob Storage, then there will be certain library in Spark using which you can connect to a AWS S3, or you can connect with the Azure, right? Similarly, if you want to connect with Hadoop, you will be using certain Hadoop library over here. You want to connect to some other kind of a storage, a local storage, you will use some other library. So there are a lot of libraries available, right? And some of them being, if the library gets mature enough and gets a lot of usage, it is added in a future version of Spark in the core library itself, right? So either it can be in a core library, or it can be in other libraries. So there are lot of libraries that are available in Spark. So let's again revise. So the full form of RDD is resilient distributed datasets, and the full form of API is application program interface. Okay, API is a general API terminology in IT. Application program interface. What do you mean by application program interface? Is you can just integrate, right, with the different programs. So you have one application, another application, you can interface it using APIs. SQL, as we know, it's a structured query language, right? SQL is a structured query language. So let us revise. So this is a Spark. We have taken this Spark and we are just zooming it, right? So we are just zooming it and we see that a Spark contains below modules. Okay. So a Spark contains below modules. At low level, what is there? What is there at low levels?
RDD,
RDD and
Broadcast variable.
broadcast and accumulator.
broadcast and accumulator. Are we going to use broadcast and accumulator anytime in the project in future as well? Very, very rare. Okay, very rare. Maybe 1 in 1,000 times. Or probably not even that. I mean, it's very rarely used, broadcast and accumulators. Just that it's available. And we'll see in one of the lectures towards the end as well. RDD, what is the full form of RDD?
Resilient distributed dataset.
Resilient distributed dataset. What does this mean, resilient distributed dataset? We'll see in some time as we go ahead. But for now, you can just consider it as RDD looks like something like a flat data, unstructured data or a flat data or just a row of data, right? So just think of it as it is just a row of data. Just think of it, think of RDD as just a row of a data.
Is it an internal data structure?
Yes, it is an internal, you can say, but you can also directly use it. So it's just a row of data, right? If I just want to write a line in an text pad, it's just like a line in a text pad. Just a row of data, nothing more than that. A single row. We'll see more in detail as we go ahead. Then a data frame or SQL or a data set comes under which API? Is it a low level or high level?
High level.
High level. What was the example we said about this? Probably a table, right?
Is
Table
a
with
tabular kind of structure.
a roll number, name, age, right? So it's a structured, right? 1, 2, A, B, 21, 22. So so high level is also called as a what?
Is a structured API.
It's a structured API. It also supports a structured streaming. Streaming means what? Is it a continuous flowing data?
It's a
Yes.
continuous flow of data.
Continuous flow of data, right? Can you also do machine learning and AI on this Hadoop or Spark?
Yes.
We can also do a machine learning or AI on Spark. It is basically a next level of whatever you learn in Python. It's a machine learning in a distributed manner, far, far fast. And there are other libraries. The example being, I want to connect into a S3 storage. I need to use certain library that is built by certain AWS guys, and they have given so that the people in Spark can also use AWS. If the people in Spark can use AWS, that means the usage of AWS will increase and they can make money. So they have to provide the support. So there are many libraries that comes in and there is an entire ecosystem. And as the library gets more and more famous and more in use, it goes from the other libraries into a main set of libraries, right? Into a core libraries. So this is about what is there inside a Spark. So what we are going to study? We are going to start studying. We will start studying with RDD. So this is the first thing that we'll be studying. And RDD. We'll study RDD. Then after RDD, we'll study data frame. Then we'll study SQL. Then we'll study dataset. Then at the end, towards the end, we'll study a broadcast and accumulator. We'll also do something on structured streaming, but we will not be doing anything on advanced analytics. Okay, there is not a machine learning course. If we have to make a machine learning course, it will be like more than if we have to cover in depth, then it will be more than 100 hours of course, right? If we want to go in depth, so we won't be doing this because it's completely a separate thing. We are doing with a data engineering point of view, not with a data science point of view, or not with a machine learning point of view. Okay, any questions until now?
How the Sparks will support the unstructured data then?
Unstructured data is used mostly with RDDs.
Okay.
So you will have to do a programming in RDD.
Okay.
Any other questions? Okay, so if no questions, then we go ahead.
One question. Will you
Yes.
be, showing me how do we do the unit testing framework in Spark along with the Spark data frame or data set,
Can
just
you come
like
again?
Scala? So will you be showing examples of the unit testing like Scala test or JUnit along with the data frame or data set? How do you really do the unit test in Spark?
Yes, yes, we will cover. It's far later. Maybe
Ah,
it comes towards the capstone project. It's far later.
okay.
Yeah.
Yeah, okay, fine.
Yeah, any DevOps kind of stuff will be good, basically, in the production, how they will do it or how that can be done.
Towards the end, I can just cover a little bit of Git and integration with Jenkins, but not really the objective of this class. But it is similar to anything you do on any of the things. I mean, you are doing a .NET developer or you are into a Java developer. It's the same. There is not much difference. But we
Yeah,
can just cover towards the end a bit.
yeah. Maybe logging, log4j implementation, real life. How do you do?
Yes, yes. That will be covered in detail in a capstone project. So the project will have all these things.
Okay.
It will be just
Uh,
like
uh,
a complete end-to-end project that you can show.
are we going to use the Cloudera cluster or the Databricks?
We won't be using both. We'll be installing our own Spark in the local Linux. So we'll be using
Okay.
Apache distribution.
Oh, okay.
Okay. Any other questions? Okay. So if no questions, then let's go ahead and let's see how the Spark started, right? How Spark started. So evolution of Spark, and it will continue to evolve. So it started in almost in 2010 when Mate Zaharia, who was doing a PhD at that time in University of Berkeley. So in University of Berkeley, he was doing a PhD, and he, along with his teammates, They wrote a paper called as on Spark, right? They wrote some Spark paper, and it started from there. And they were basically working with all the people who are actually working on Hadoop and trying to understand what is the problem with Hadoop and how they can make it better and so on, right? So it started in 2010. The first momentum that it got was in 2014. Okay, so in 2014 the one version was released, so it was the first major version, right? 1.2, the first major version was released in 2014, as well as it was at that time only it was made an open source to Apache Software Foundation. And this Mates area with a couple of other guys, he made his own company, and the name of the company was Databricks. So Databricks was formed. Then the next milestone was in 2016, wherein 2.0 was released. And the latest milestone was in 2020, uh, I think so in August, when 3.0 was released. Okay. So why I should be knowing this is because when I go, I've seen people writing resume saying that I worked on Spark 2.0 in 2015. How the hell you can write in 2015 when it was released in 2016, right? So all this matters. People don't know what is a version of the Spark they have worked on, and that's right. That's so it does matter. So few of the versions that gained momentum or were in use was 1.6, 2.1, and 2.4, right? So the early adopters of the Spark who adopted really early in 2015, and they started writing in code in Spark as well, because Cloudera Hortonworks was also distributing with this thing. So who started in 2015 and all, they were working on 1.6. So and if someone was working in 1.6, they were writing the code in RDD at the lower level. They were writing the code in RDD. Data frame was also available over here, but it was still not much stable or a bit of experimental kind of. People who were working in 2.1 and 2.4, they are either writing the code in data frame or dataset. Again, there is not much difference between data frame and dataset. We'll see when we study. So they were writing a code in data frame or a dataset. Again, when the 3.0 came in 2020, there is not a major difference. There is no major change as such in the terms of syntax and all. Internally, it has changed a lot. The Spark is much more faster now in 2020. But again, it's just 3 or 4 months it has been released, and I haven't seen anyone being adopting, or maybe if someone is adopting, I mean, it's a more agile company and so on. But big companies won't really change so quickly. They will take good amount of time. As well as the new Spark that came 3.0, it has a very it's more improved in speed and performance, especially in SQL processing, and as well as it has got more better support for machine learning libraries. So 3.0 has a more better support on machine learning libraries. Again, we are not doing a machine learning, so it doesn't really make much interest. But if you're going to work on Spark, if you're already working, it's either of these three versions you're working on, either 1.6 or 2.1 or 2.4. You may also be working on 2.2, 2.3, but less chances are there. Most chances are that you're working on 1.6 or 2.1 or 2.4, depending on what year your company actually adopted using Spark, right? And to say that whatever we will be working in this training, we will be working on 2.4, right? Again, if you want to run the same piece of code on Spark 3.0, you can also run on 3.0, right? I can also install 3.0, but I don't want to install actually because that's what you will be working as of now. And but if you want to write the same code on 3.0, you can write 3.0. If you want to install 3.0, you can also install 3.0 as well. I will be showing you in the next sessions how you will be installing all this. Uh, but we'll be doing all this in a Spark 2.4, not on 3.0 or any other version. We'll be working on Spark 2.4, that is more majorly used and many things that support this, right? Okay. So let's quickly revise what we have discussed so far. So we discussed that when did Spark start? Which year? Which year Spark started?
10, 2010.
Key person name?
Matti Zaharia,
It is area, right? And he was doing a PhD from which institute?
Berkeley.
Okay, perfect. And he wrote some paper on Spark. I don't know the name of paper, but he wrote some paper and he made some systems and so on. What year it was open source and the first version came in 1.0?
2014.
And what was the company these guys formed?
Databricks.
Databricks. And the next 2.0 version, what year?
16.
16. And what was the version in 2020?
3.
3. So 3 was kind of a release by this Mates area and all. You can watch the video on YouTube as well that uh, to mark the 10 years of Spark, they released 3.0. More, but more from machine learning perspective. There is more things from a machine learning perspective, right? So this is about history. Any question about the how the Spark actually evolved and what is the history of Spark?
No, in production, does the RDD is used on the data frame nowadays more in use?
Okay, that's a good question. So nowadays from Spark 2.0, Spark always promotes you should be using data frame or data sets. Don't use RDD unless it is very much necessary. Okay, so you don't
Okay.
have to use RDD, you have to use
So,
data frame or data set from Spark 2.0.
but we still need to learn the RDD for the historical reason or any other reason is there?
Okay, so another reason is you may have to run in RDD in certain cases that we'll see in next classes. What are the reasons? Or what are the places you may have to write in RDD? The one of the case can be simply because uh, you are supporting a legacy code, so you need to learn. Second thing is a data frame and data set is nothing but it is built on top of RDD. Okay, so data frame consists of RDDs only. Data set consists of RDDs only. And if you want to see internally how the things are going on, the Spark shows everything in RDD, right? So if you write a code, it is not working. When you want to deep dive and see why it is not actually working, the Spark is going to give you all the explanation in RDD. You won't understand unless you understand RDD. So, will you be writing a code in RDD or not? The answer is no. You won't be writing a RDD code. But why you still want to learn? Probably you want to support a legacy code, or probably you are working on an unstructured data that cannot be worked on data frame. As well as if you want to deep dive, the whole intention of this course is in depth. So if you want to deep dive into it, you want to understand what is happening internally. Tomorrow when you're working on a job and you're stuck somewhere, you want to see what is the happening, read and understand, then you need to know RDD.
Thanks.
Okay. Any other questions? Okay.
Will we be discussing about DAG?
Yes, yes, we'll be discussing on DAG. A lot of time to go into DAG.
Okay,
Yeah.
okay. Yeah.
Okay. Any other questions?
Since he talked about DAG, right? We'll be looking into the execution plan, the caching, and the Spark UI that
Yes, yes. Yes,
data
we'll look
use,
into all
right?
those. Yes, yes, we'll be looking into all those. Okay. Any other questions? Okay. So if no questions, then let's go ahead and okay, let's go ahead. So when you write the program in Spark, let's say you're building some applications, writing some basically a code, right? So let's say you are building an application in Spark, right? So as you know that, I mean, if you have written a Java program, Scala is not different from it. You always start with a main function, right? Something a main function. So whatever you write into a main function, that is going to be executed. Whatever you have written in a main function, whatever you have written, that is going to be executed. For the execution purpose, there are two components. One is called as a driver, and the second component is called as an executor. Okay. So the first one is the driver and second one is a executor. So what will driver do? Driver is the one that is going to see what is the main functions or whatever program you have written. But will the driver execute it? No. The execution will be done by the executor. Okay. So what does a driver do? A driver is going to control the flow of program, right? Control flow of program, right? So this is the one who is controlling the flow of the program. And what is the executor doing? It is the one who is actually executing the program. Okay, this is the one who is executing all the task. Okay, so what is the driver doing? It is going to say to the executor, okay, do this. And the executor is one that is going to obey the instruction and say to the driver, okay, I am doing, okay, it is done, and so on, right? So there are two components that you need to know. The first one, when you are building any application in Spark, there are two components. The first one is called as a driver, and second one is called as an executor. Okay. Let's say in the main program, I am writing load some data from HDFS. I'm saying that load some amount of data from HDFS. I am saying a load some amount of data from HDFS. So will the driver load this data or executor will load the data? Who is going to load the data from HDFS?
Executor will load the data. Driver will instruct them.
Okay, so driver is the one who is going to instruct to executor, okay boss, just load the data into a data frame or whatever, data frame, data set, RDD, whatever, right? So it is going to execute it. So let's understand how does it execute. So there are two components. One is a driver and second component is called as a executor. Okay, so there is two component, there is a driver and there is a executor. For communication between driver and executors, as well as to take care of resource management, there is a resource manager. This is a resource manager. Can you give some example of resource managers?
Is it Yarn?
Jan, any other?
Mesos?
Mesos, any other? Standalone?
Yeah, or the Kubernetes or the
Kubernetes, right?
Docker.
Kubernetes and Docker, right? Kubernetes and Docker. Or any other container platform for that matter, may not necessarily be a Docker. It can be any other container platform, right? So there is a driver, there is an executor. Okay. Is Spark doing a processing in a single computer or it is doing in a multiple computers?
Multiple.
It is doing a multiple computer, right? It is meant to do a processing on a cluster. It is built to do a processing on a cluster. If you want to do a single computer, you can just write a normal Java program, Scala program. Why you need a Spark for it, right? It's developed to do mainly for a multi-computer, though you can also do on a single computer. That's a separate thing. It's mainly built for a multiple computers. Now, if it is for a multiple computer, will I have a single executor or a multiple executors?
Multiple executor.
Multiple executor. Good. So I will draw multiple executor. Let's say I'm drawing three executor. And these three executors, whatever I'm drawing, they are going to communicate together. Okay. So this is basically all the executors. I just make a dotted line out of it. And these are all the executors that are just communicating with via the resource manager, right? So this is my executor. Now there will be how many drivers? One driver or multiple driver?
One.
One only, right? So there will be a single driver because one person will only say, na, do this, do that. It's like just like a manager. There is one manager and 10 resources. The one manager says to 10 resources, do this, do that. If there are multiple managers, you already know what happens in an office. So there is one manager and there are multiple executors, right? So whatever a person has written a code is over here. So a person who writes a code, this is my code that is getting executed, right? There is my main program or whatever code I have written is over here and it will communicate with it. Also always remember that there is an important thing that is created always that is called as a Spark session. Okay, so it's basically a session is created so that all the memory is allocated and so on, and it is allocated to a particular session and so on. So there is a Spark session that will be created that will be part of the entire driver process itself. So there is a driver process that is running. There is a user code that is the user has written. Every time it will start with creation of a session. We will be seeing in the program as well also. So it starts with the creation of a session, and below is the Jan and Mesos and all the resource manager via which it communicates with executor, right? So this is how the entire program is executed. It consists of two things: a driver, which is going to control and say to executor that okay, do this, do that, and whatever. An executor will actually execute the task and say that okay, boss, I have done this. Okay, boss, I have done that, and so on, right? So executor is the one who is actually performing, and driver is the one that is actually saying what to do and what not to do. Let's go ahead. Now, as we said that there are four programming languages that are supported: Scala, Java, uh, Python, and R. These are the four programming languages. Scala and Java are the same thing. It's not different. If you have not learned, I will strongly say you also listen to the Scala videos on Udemy. It runs on a JVM platform only, so it's not different. Scala is just like an abstract on top of Java, just like encapsulate another layer built on top of it. Java is hidden behind the scenes, and it has its own syntax and certain things, but at the end of day, it gets, when you compile it, the same kind of a jar program is created. It's the same jar file that is created, right? The same jar file will be created. So Scala is not different than Java. So whenever you run a particular executor that we discussed, saw in the previous slide, there was an executor, and it runs in a JVM. It runs in a Java virtual machine. So whenever a new Spark session is created, the Spark session is going to run in a JVM, right? It is going to run in a JVM, Java Virtual Machine. It's going to run over here. But JVM can only run these two things. It can only run Scala and Java. It cannot run Python. It cannot run R. So to run Python and R, there are two things. To run Python and R, there are two things. One is a separate execution for a Python, and one is a separate execution for R. And there is a overhead involved over here because you have to do a serialization and deserialization again and again, right? So it's not a natively compatible, right? It's a separate thing. So whenever you are going to write a code in Python, or you are going to write a code in R, it is, you will need a serialization and deserialization and so on, and obviously it will be very slow, or not very slow, but comparatively slower as compared to writing in Scala and Java. Then again, you say a .NET is available in Microsoft. I'm not aware. Maybe they have modified this version because everything is open source, and they must have put a .NET and all those things, VB and whatever. But this is how the Spark actually comes in, and it is used, right? So, any questions until now?
Does the knowledge of Java is required to learn Spark? Because I'm coming from the .NET or C# background.
Okay, that's a good question. So you have to learn at least one of the programming languages. If you're going for a data engineering, for which this course is designed, it's enough for you to learn Scala. No need to learn Java again. All the concepts are covered in that, so no need to learn Java. It's enough if you learn Scala. Okay, any other questions? Similarly, if you are going for a data science or machine learning role, it's enough if you know Python. No need to know Scala. It's okay if you know Python if you're going for a machine learning or data science. But since this is for data engineering, Scala is enough, and you can do Spark again over it.
So for Python, if we have a program in Python and then it runs on a Spark thing, do we need any other, like another process or something to make it work? Because you said we might require a serialization, deserialization to speak to the JVM.
Right. So we don't have to code for it. Once you use the Spark libraries, the PySpark, it will take care of it. You don't have to write separately, it will happen automatically.
Okay, so it's PySpark library, we can use it.
Right.
Okay, thank you.
Okay, one question from my side. So a JVM means an executor means one JVM, right? Per executor. If you got three,
yes, right,
there will be only one JVM.
right.
Okay.
Okay, any other questions? Okay, if no questions, then let's just have a look and feel of a Spark. How does it look? So let me just start a Cloudera, not Cloudera, Oracle VM. So this is my Hadoop installation on Ubuntu 20.04. I will be sharing this VM with you guys. So just double click or click and start. So the VM will start. So it has started. I'm entering my user ID and password. So it's a Linux installation Ubuntu 20.04. So Ubuntu comes with two versions every year, 20.04 and 2010. 4 being April release, or 10 is October release, mainly with the fixes. 2010 don't have a long support, so don't prefer that. If you are using Ubuntu, use anyone with the 4 series April release. So just to give the steps on how to start, I mean, we'll see later on. We'll be seeing it later on. How do you do a installation and all? But let's just have a look and feel of whatever we discussed till now. So these are the steps to start. And what we'll do is we'll start a terminal. So I started this. Let me move it to this side. Let me zoom it a bit. Okay. So I'm going to start all these things. Start DFS. Okay. So start dfs.sh is to start the file system, Hadoop distributed file system. So I'm starting a file system over here. At the same time, while the file system starts, I'm also starting a yarn. So what is yarn?
Resource.
Resource manager, right? So let both of these things start, and then we are going to start the Hive Metastore service. Again, it's just a SQL kind of a database and a query engine that was built by a Facebook on Hadoop. We won't be discussing much. You can listen to it on Udemy, a big data Hadoop course. So it will be there in a big data Hadoop course. You can listen to it on what is Hive over there. So let's start a Hive. So Yarn has started. File system is starting. Okay, till the time it is starting, I just give you a brief walkthrough, not in much detail. For more detail, you can learn Hadoop course on Udemy, or you must have learned. So when you are starting a Hadoop, it is starting the name node. So name node is a master which controls all the computers connected in parallel slaves. So it has started a name node. Then it has started a data node. Data node is a slave. So all the slaves, right? So it has started a data node. So it has started a name node. It has started a data node, and it has also started a secondary name node. So secondary name node is like a service that is required for refreshing the metadata in name node, right? So these are the three things that are needed. Name node, that is a master; data node, that is a slave; and the secondary name node, which is used to update the metadata. For more details, you can listen to Hadoop videos. Then we have started a resource manager for getting resources and all, and we have started a Hive. It's a no hope, meaning it will keep running. Okay, so we have started this. Then we have to start a Spark. I can just uh, start another thing. You can also write anywhere. So I'm just starting a Spark. Give the entire path uh, because it is also there in different places. The same program. So for Spark, give a entire path Spark home slash sbin slash start on dot sh. If you just write start on dot sh, it will bring something else up. So start on dot sh. So it is bringing up the Spark, right? So it has brought up the Spark, and if I want to work, so these are like a basic thing. You have to bring up the service because you are working personally on a machine. Had it been a cluster on your office cluster or something, you don't have to worry. This admin will bring up and everything will be always up. So you don't have to bring this up. It's just because it's my own machine where I have installed, so I have to bring this all up. If you are working in any of the office thing or something, so it will be always up. You don't have to worry. You just have to start the Spark shell. So Spark shell is basically a command for starting the Spark shell, right? So Spark shell, Spark shell is the command to start Scala Spark shell. For if you are in Python, then you will be writing PySpark. If you are doing for R, you will be writing Spark R. For Java, you don't have a shell. You don't have a shell. You don't have shell. Okay. You will only have to write an entire program. You don't have a shell over there. You cannot do a command line coding. No command line interface. No CLI. No command line interface. Okay. You cannot do on a command line. So I've written a Spark shell, and it says that it is resolving some IP addresses and all. Let's leave it. Just says that Spark R use this. It says that you can currently it is all the warnings and above will be shown. So if you are writing anything, the log level is warn. So log level warn meaning you can see there are basically three log levels: info, info, warn, error. Default it is set as warn. Okay. So if you set it warn, it will show you warning and it will show you error. If you set warn. If you set error, it will only show you error. If you set it info, it will show you everything, right? So info meaning it will show you everything. If you set the log level to warning, it will show you warning and error. If you set the log level to error, it will show you only error, right? So what is the log level that is set over here? What is the log level that is set over here?
One.
Warning, right?
Yeah.
It will show you both one. It will show warning. Uh, Let me maximize. So it says that you can also change it to a new level. So it says that I can change it to something else. Set sc dot set log level to, okay, I set it to error. So it will change it to error. Now it will only show errors. If I run anything, it will not show me error any other thing. I can also change it to info. If I change it to info, it will show all the information every time I run any of the code. So uh, it says that the default log level is this. It says that there is a web UI that is available over here, and I say that I right click over here and I say open link. So it will open the link. So it says that web UI is also open over here, so you can go and see in web UI, right? So you can, this is the web UI. Currently it won't show much. It's just that user ID, it was up in how much time, scheduling is first in first out. The Spark version you can see on the top is 2.4.4, and all these things will be blank now because we have not done anything, right? So whatever things you will see over here, even if you are working in data frame, you will be able to see the detail in RDD. So always learn RDD as well. So it says that Spark context is started and it is available in this IP, and you can see that a Spark session is available, right? And Spark session is with the name Spark. Context is with SC. So we'll see what is context, what is Spark session more as we go ahead. The Spark version, what is the version of Spark over here?
2.4.
2.4.4. Scala 2.11.12. Java 1.8.0. There are people I have seen who, if you ask what is the version, he say I am working for multiple client, I don't recall. Okay, how do you check the version? I don't know how to check the version. Okay, and so I mean, so even if you have come till here, you know more than the people who reach interviews as well. Okay, so this is all I wanted to cover. So this is just a gist of how a Spark shell will look like. Okay, any questions still here?
Is there a separate command to check the version explicitly? I mean, when it starts up, obviously it shows up. But
Yes,
what is
you
that?
can check just like a Linux Spark dash dash version, Spark dash
Oh,
dash help. Yes,
okay, okay. Thank you.
but the simplest way is this one. You can also go into UI of here, and UI will also show the version, and wherever it is installed, you can do where Spark, and you can use your Linux skills to find where the Spark is installed and go there and check the versions. Okay, any other questions? Okay, so if no questions, we'll end here. We are 5 minutes over the time, so we'll end here and we'll continue tomorrow, same time.